Welcome to Time to AI. I'm Jason Turpin. Hang on tight. Today we're going to talk about Imagine Databases. Imagine Database is an AI application I created that generates a database from any concept whatsoever via two chained LLM calls. I came up with this while I was camping on September 9th, 2023. I like to go coding and camping. I feel I see farther when I'm surrounded by nature. I think this all comes from an dangerous early childhood exposure to Monty Python. Anyway, let's do this. Leroy Jenkins. We're going to start with some demos, move to a functional overview, and then do a deep dive into the LLM prompts that are being used. Finally, I'll do a quick overview of the application implementation. All of the code on display is up on GitHub. Check the video description for the link. Now then, let's take it for a test drive. All calls are going through GPT-4 Turbo on Azure OpenAI services. You give it a concept, anything from 1 to thousands of words, and it returns a relational database script about it. For our first example, we're going to choose something kind of comical, Batman's Cave. While this is a trademarked and copyrighted topic, a lot of public material references Batman. The store of knowledge in LLMs is rather vast, so it's aware of Batman's Cave. I do want to point out that this process isn't fast. I'm making two LLM calls, with the first doing most of the thinking, and it also takes the longest. The second call is effectively reformatting the results of the first into a database creation script. Alright, there we go. Let's take a look at the example. Let's take a look at the results. So we've got tables, location, equipment technology, suit gear storage, trophy room, database archives, villain profiles, living quarters, maintenance schedule, service log, user authorization, vehicle inventory. A whole lot of information, all referentially valid about Batman's Cave. Let's do another example. This one's my actual personal favorite. It is the word muon. Now I like this example because people respond in one of two ways. They either don't know what a muon is and are amazed that the system does and is aware of it in the manner you'll see, or they know what a muon is and they're pretty amazed at what the system pulls together from this. And let's take a look at this. For the record, a muon is an elementary particle in physics. So what do we have here? Interaction types, decay modes, particles, particle properties, leptons and quarks, force carriers, the infamous Higgs boson, standard model particle interactions, particle decay models, and standard model components. Interestingly enough, this one didn't give me a table called muon, which it normally would do. I'm going to go ahead and show you how this is a creative system, and you'll get different results as you go. So I'm going to clear that, and we're going to do muon again real quick just to see what the results look like. Okay, let's take a look at these examples, a little bit different this time. And as I said, it can be different every time because it's being creative for the first response. In this case, we do have a muon table along with information about it. And up here still particle types, some fundamental interactions and decay products. And muon decay products down there. So a little bit different database structure there. So let's take a look at something that's a little bit more realistic in terms of what you might want a system to be composed of. So let's choose something I have a little bit of experience with. How about an OFAC monitoring and clearance system? Alright, OFAC. OFAC stands for the Office of Foreign Asset Control. Financial services industries use it to vet people who can see who can participate in our financial system. So let's take a look at what we got here. User information, that would be transaction details, OFAC list details, sanctions programs, there you go. Screening results, system user management, and compliance workflow. These, when you get an OFAC hit, you have to have it cleared, you have to vet it and determine if it's something you need to refer to the authorities, for instance. Compliance auditing, reporting capabilities. I don't really like this one too much, but this is a reasonable start as a wireframe for an actual system, but if you're performing OFAC checks, you're probably dealing with SOX as well, so good luck with that. So let's move on to the next example. In this case, I'm going to use look in the instructions. There's that little bit about, if you don't want to create a response, include just generate this in your description. So here we go, just generate this. Create a table called address with city, street, city, state, and zip. Create a table called states with abbreviations and state names. Relate the tables. Let's see what it does. And there we go. Didn't even take very long. There's our states table, there's our addresses table, and the foreign key reference to it. It's exactly what I asked for. For the next example, I'm going to use the AdventureWorks database by Microsoft, but what I actually did is I used ChatGPT to obtain a description of the database. It's far more detailed. So here we go. So here we have the entire database description. AdventureWorks database is a fictitious sample database created by Microsoft. It has persons, human resources, sales, production, purchasing, all of these different facets and aspects. And I'm just going to grab this whole darn thing and stick it into Imagine Databases. I'm not going to tell it to be I'm not going to bother worrying about creativity, and we'll talk about that, why I'm not, in a few minutes. A couple minutes. Here we go. Alright, let's take a peek at what it did here for the AdventureWorks database, which has a rather extensive description. Starting at the top: person, user account, customer, employee, department, job candidate, training record, shift schedule, sales order, product, category, bill of materials, supplier, machine maintenance, purchase order, vendor, supplier evaluation, inventory management, product inventory, credit, address, product review, employee pay history, special offer, employee benefits. Holy mackerel, it's quite a database. I'm going to grab that for right now and save it for later. So, let's do one more example real quick. Just want to show you, you can give it anything whatsoever and it'll generate a database software. So, being a generalist, I'm going to go ahead and go as general as possible. We're just going to type in the word stuff. See if you can guess what this might do. If you were to create a database about stuff, what would it be? What would it be composed of? What would it be about? Generally. Alright, let's take a look. What do we got here for stuff? We have a category. We have an item. We have a supplier, so it's creating like a database of things. Supplier item, doing a linkage up. Customer, okay, so it's actually more of a sales type of thing, as we have a transaction table as well. Warehouse, so it's getting into the storage of all of our stuff. It reminds me of Carlin here. Warehouse items. Communication type, in case we're communicating about our stuff. Dress, customer dress, supplier dress. I didn't know it usually doesn't go this in depth with this. That's funny. Good stuff. So, anyway, that's a bunch of examples. So what's going on here? I pass in a single word, say muon, and get back a thoughtful, structured, and useful output. The key is a simple pattern of two calls to the large language model, passing the results from the first as part of the input to the second. The first call is creative, asking for the system to expand on the concept and the concept's domain. This step utilizes the knowledge base inherent to the model. It maximizes creativeness, and randomness. It is executed with a high temperature and top p-values, both 1. The second prompt takes the output from the first with instructions to create a database script for it. It is not creative. It is executed with a low temperature and top p-values, both 0. Let's take a look at the prompts. Here's the first one. The first line gives the LLM an overview, kind of giving a concept of what's happening here, that sort of thing. Note that I'm not asking for a database, but I'm suggesting there will be one. The next section is behavioral. I'm calling out situations where creativity shouldn't be applied. If the user says, just generate this, that's kind of forcing it to not be creative. And then it kind of gets a little bit weirder, like if the user asks you not to be creative. So not just generate this, maybe, don't embellish, whatever. And number 3, if the concept is already detailed. Otherwise, just return the concept as is, and it will just literally boilerplate back exactly what the input was. So anyway, the first is very specific. If the phrase, just generate this, is present, that's what it does. The second is descriptive, but ultimately subjective. What is not creative? I'll leave it to the model to decide. And the third is very subjective. Who is to say a concept is detailed? In this case, the model. Then, if it's determined that creativity should be used, the next section gives the LLM guidance in the form of roles to use and instructions. Here's where I'm asking it to delve into whatever concept was provided. After that, there are additional instructions. I'd like to call your attention to this particular line. Ideally, we would like to have a minimum of 6 concepts represented if this makes sense in the conceptual domain. Right there, I'm asking it to bring a certain amount of detail to its response and tell it to be, and especially when it's being creative, kind of like ask, what is the domain of the topic that has been provided? So, on to the second prompt, which is straightforward in its intent. The Key to effective prompts is being specific in your ask. I had to iterate a few times to deal with error and occasional extraneous outputs, which obviously will still happen. This prompt gets right to it, very explicitly defining the result. In this case, I'm requesting a SQLite database script, which differs from standard ANSI SQL, so I had to call out that database by name. You can specify whatever type of database. After that, there's additional specifications and several defensive phrases because the model likes to spit out extra stuff. And I don't want the extra stuff there for very specific reasons. Specifically, because I want to be able to try and do something like this. Okay, so what I have here is an empty SQLite database. And I'm going to take that script from before. There it is, the whole thing. I'm not going to touch it. Haven't touched it. Hands off. The whole thing from person down to the bottom of employee benefits. I'm just going to hit the F5 key. As you can see, it created the whole table. And I want the script to be really pure in terms of I want the script to be executable at the end. That was kind of one of my goals. So what we're going to do now is we're going to take a look at the user interface implementation. What does the code look like for this entire application? There's all the code right there. 37 lines at the bottom. I got some of it boxed up a little bit for brevity to make it look short. That's the entire code base. It's using a user interface technology called Gradio, which is a Python library for building lightweight interfaces specifically around large language model and machine learning models. So let's take a quick look at this. These two lines right here define two text areas. If we go back to Imagine Databases, there we go. You can see the interface. Right here we got the two text areas, describe your database, generated scripts, describe your database, generated scripts. This right here actually creates the app, so it just populates the user interface with those two controls. Then down here, this actually creates the app. This creates an instance of the app and doesn't run it. That's the next line. But and the way this works is it takes a function as an input and then determines the inputs and outputs. So when this form is submitted, database generator is the method called when the form is submitted. Up here you can see it. This is it right here. Oops. Database description is derived from calling that first prompt, and then that database description is passed in as a value, it's a parameter to the generated database, and that's it. Those two lines of code do the whole thing. That's it. That's the secret sauce. Those two lines of code, and these lines give you my user interface, and you get this. I got my description right here. There's all those words. If you're looking for a database script, there's all that stuff. Here's the examples. That's going to be anything. They're down here. One really interesting thing about Gradio. So this app.launch starts it up, and you can see down here. Let me restart it. Not only does it start up a little local web server and expose it to you locally, but if you do this share equals true, it lights up a publicly facing URL. And so right there's the local. Follow that link. There, I've Imagine Databases local. And give it a few seconds. And what it's doing is it's creating a pipe, basically, or it sets up a pipe into my local box. And if somebody used, where's it at? There it is. Right there, running on public URL. It's completely public. Anyone on the internet could hit this right now. Once I stop the program, it will no longer work. And if I start the program back up, it starts with another URL. This is pretty sweet, though. There it is. I'm going to type in. I'll do move on again. Let's start it. And you can see over here, down here, it'll show me that I'm submitting stuff. Starting as our opening I call prompt length 1500 characters. Here's the concept. Move on. So it just got started making that to run that. So it's pretty cool. Gradio's nice for doing very basic, simple, and fast type of chat interfaces, you know. Pretty good stuff. Anyway, that's Imagine Databases. It's rather powerful in its simplicity, and it's a great example of the power of current large language models to use creativity to expand upon a concept and then return a formatted useful output. Question: how long would it take you to work out a database design from a concept in a manner like this? It's an interesting question. I hope you found this informative, if not exciting. Like and subscribe, and have a good one.